So learners, welcome to our lesson today. And our lesson today will be ways of increasing friction. In our first lesson about friction, we mentioned what friction is, and we said is a movement, is a force that opposes movement or motion. So today we want to see how last week we also saw that friction is important when someone is working, when someone is writing on the board, on the book, when one is erasing the blackboard. Okay, even during movement of vehicles, friction is very important. Now I want to see how we can be able to increase friction. In case a service doesn't have friction, what can we do to increase friction? So we begin by looking at what I just did yesterday about treads. Talked about a car that is having treads. So we call these treads. So one way of increasing friction is use of treads. Use of treads, either in a tires, or even shoe soles. Shoe soles. So if you want to have a grip of the ground, a smooth ground, you need to have treads on your shoe at the sole, or even the car. For it not to skid, it needs to have treads. So that's one way, so that to enhance grip on the road. So one way of increasing friction is by use of treads, which are found in car tires or even shoes. Number two, talk about spreading coarse materials. Spreading coarse materials on the smooth surface, on the slippery surface. Remember, our aim is to make that place to be very rough. So for example, if a place is slippery, you have seen many times your parents or even whoever you stay with pick some sand and brings at that point where it is very slippery. You can also bring maram. Some of these materials are maram. Talk about sand. Sand is another one because sand is rough. Talk about sawdust. You smear where the ground is slippery. And also sawdust is used in carpentry. I don't know whether you know that. For fundis to be able to connect one piece of wood to the other without necessarily using nails, they use glue and sawdust. So they ensure that the glue is mixed with sawdust, and then because that sawdust brings about roughness, so that they smear the glue together with the sawdust. Then when they bring the two pieces together, they can be able to attach on one another. So the other way, of course, is increasing weight. Increasing weight. For example, I told you a practical that you can be able to do back at home. When you have a carton, then you have a few books, like 3 books. It's very easy for you to be able to move it on a smooth floor. But now when you increase the number of books to become 50 in this case, it's very difficult for you to be able to push. That means as you continue increasing the number of books, the box gets a grip on the ground. So we know, we talk about pressure. So the pressure towards the bottom of the box becomes so much that it is pressing on the ground like this. When they were 3 or 2, it was not pressing so much, so you can be able to push it. But when they become 50, that's why you can be able to move a log. But a small piece of wood, you can move it on the ground because of the weight of that particular material. So when you increase weight of objects, they have a more grip on the ground, and so that increases the friction. That is the force that opposes motion in between the surface of the bottom surface of the box and the ground, the slippery ground. So we can do that by increasing the weight of the materials. so that they can grip well on the ground. Lastly, second last, that is roughening surfaces. Roughening surfaces. You roughen surface, you make a surface very rough. When you make it so rough, like what we are doing here, what we are doing in this car tire, we are roughening this part because it became smooth. When this stress got worn out, the tire part, this part became smooth. So the opposite of rough is smooth. So for us to be able to have a grip again, we roughen this by doing some threading. We thread this particular tire. It becomes rough. So this roughness is the one that is able to grip the rod. But if it's very smooth, it cannot grip the rod well because there are no these specific features that are required in gripping the rod. Of course, the last one about roughening, about ways of increasing friction will be use of adhesives. Now, in this case, adhesives are things like glue. Many times, when you want to use glue increases friction. I want to give you an example. Look at your bicycle at home. Sometimes you pass through areas which are not so clean, and then they get puncture. So you take it to the fundi. You realize that when the fundi removes the tube, that rubber part of it inside the tire, and wants to mend it, what happens? He first scratches it with something rough. This part becomes rough where the hole is. Becomes rough around that place. Then he picks glue, very thick one, applies here. Then he finds another piece of tube, that is rubber, which is the same size of this. So he again roughens this very fast, and then places some glue here. So he brings this one and places over this one, and that one will mend the hole. So this surface and this is able to be combined because of that particular glue. You first make the surface very rough, and then when you bring the two of them together, they can be able to join. So use of that adhesives can also increase friction. The grip, this one is able to grip this because of the friction in between them. So that's how we can be able to increase friction. So very fast, let's move to the ways of reducing friction. One now to reduce friction. There are areas where we don't need friction, and so we need to reduce the friction, reducing friction. Now, way number one of reducing friction is use of rollers. And rollers are of two types. You can have rollers which are ball bearings, and we have rollers which are roller bearings. Roller bearings. I want to explain the two terminologies here used. We have ball bearings. I am sure if you want to know this well, just ask your dad to show you a ball bearing, or maybe a car. You find something like this. If you look at a bearing, looks like this. Now what I've drawn there, inside here, we have balls. Round things, very round. So when the car is moving, the whole axle does not move. It's only this part which moves. So that way it can be able to move. The vehicle can be able to move. So here we have balls. That's why we call them ball bearings. But they are fixed inside a particular piece of metal, which is round like this. So this one is the one that rotates. The axle does not rotate, because if the axle will rotate, it will just get worn out. So this thing rotates inside here. The axle is inside there. So what we call ball bearings. Now, when you talk about roller bearings, I want you to take, for example, you have a piece of wood. You want to move this piece of wood. It's a log of wood you have cut piece of wood and you want to move it. It's very difficult for you to be able to push it on the ground without these things. Now what are these, what we call roller bearings? These are cylindrical shaped pieces of wood, cylindrical, and they are round. They are round such that they can move smoothly. If you want, I want you to look at this. Between this type of material and this one, which can move easily and smoothly on the ground, this one can move. That's why we make them like this, cylindrical, and they are very smooth. So you move this log along those. You just push it along these rollers. So what happens when you push on one side? Of course, some of them will be left alone without a lock. So you pick them and place them in the front there. You continue pushing them like that. 3 are left here. You pile them on the other side in the front. Or you continue pushing and the lock can be able to go further. So we are saying use of rollers. The rollers are of two types: ball bearings, which are bought, of course, from market, and roller bearings, which can be able to just cut pieces of tree that are cylindrical in shape. The other way of reducing friction, of course, is smoothing surfaces. We have talked about roughening surfaces. So the opposite of that is smoothing surfaces. Sometimes you go to the fundi, and after doing, the fundi has done the table. The table is then polished so well. It is smoothened so well that when you place your hands and you be able to, maybe you're dusting it off, your hands will not be injured. So you smoothen a surface so that even if you push that thing on that surface, it goes smoothly. That's why a smooth floor can lead to accident at home. Maybe when you're washing it using some soap, some detergent. So you need to be very careful. You can step on it and then fall down because it's smooth. But when it's rough, you can be able to walk it on it very, very fast and easily. The other one, of course, is using lubricants. I mentioned this last time I was talking about ways of reducing friction, and we're talking about using of lubricants. Lubricants are of two types. We have oil and grease. I said this one because these are two substances. You place them, for example, you have your wheelbarrow like that, then there is an axle there. So you place them in between the axle and the wheel of the wheelbarrow. So what happens? It provides a service between the axle and the wheel, where that prevents complete attachment or complete contact of the wheel, the metal wheel, axle and the wheel. So that this axle does not run on the wheel, leading to this all becoming bigger and bigger every day because it has been worn out. So that is a substance that enhances smooth moving of that particular wheel. That's why if a wheelbarrow that is not oiled or greased, you hear it producing some sound, some voices. That sound is because the metal is lying on the other metal of the wheel. But when you oil it, that sound goes away because you have provided a cover in between. There's a surface in between which has been created, a thin film in between the two metals that has been created, so that the axle does not lie on the wheel. So the wheel moves smoothly, depending on that grease you have put there. So that's how we reduce friction. So because of that, you will not hear the voices. The place will not become so hot, because we say when there's friction, there's production of unwanted heat. So there is no, even if you go and touch it, it is going to be very cold because there is no friction between the axle and the wheel. That's why you even see that in the engines, maybe for a vehicle or a motorcycle, they put oil. And that oil, after some time, after maybe 1 month, it comes out very black. Because the oil has been put inside the machine where it rotates. So that the machine will rotate on that oil and prevent it from coming into contact with metals. if it comes into contact with the metals, you hear some sound being produced, and also there will be a lot of heating, and at the same time you realize that it's going to be worn out, and you will be needed to maybe acquire a new one. Number 4 way of reducing friction is streamlining. Streamlining. This is not something new to us. I want you to look at how a fish looks like. Observe fish at home. I cannot draw so well, but I know you have seen fish looks like this, something like this. Some gills there. Look at the shape of the fish. Look at the aeroplane. An aeroplane looks like this. Look at it. There's a reason why the front part of it is made like that. To reduce friction. To reduce friction. I want you to this moving on water, that is water. This is moving in air. So what happens? As water moves, maybe in a river or even an ocean. So as the water comes to meet this fish, only a few currents are going to meet the fish. The others will be cutting, they will be cut by this sharp point. So they will be passing on the sides. And so the fish is going to move very fast because only one is pushing the fish backward. But the others are passing on the sides because they have been able to be cut by that sharp part. Look at the arrow, the arrowhead. The arrowhead looks like that. So that when it's thrown by the hunter, it can be able to pass through the air, and maybe even when it reaches the animal, it can just enter through the animal and cut it because of the sharp point here. So many of the currents will move on this side. Only one will be pushing it back, and so it's going to be able to move very fast. Look at the aeroplane. As the aeroplane flies on the air, what happens? Only few air currents are coming into contact with the front part of the aeroplane. The others are just passing on the sides like this, so you can be able to see. And so this one enhances movement in air, and this enhances movement in water. Something else I mentioned, though it will be mentioned in class 8, that the scales of the fish, they don't point like that. They point backwards. And look at the way they are. They are also streamlined, so that the fish will not be pushed back as it moves in water. So the water will be passing through like this. So the fish is able to move very fast. Other than that, this fish also has a slim mucus on top of the scales. Why? To be able to lubricate the fish, and so there's very minimal friction between the body of the fish and the water. So there's some slim mucus here, slim mucus on the surface of the fish, so that water is going to move very freely and avoid coming into contact with the body of the fish, thereby pushing it backward and preventing its motion. So streamlining, you make something to be this shape, a V shape like this, a V shape like that. Look at the cars. The cars are not a block. They cannot appear like this. And this is the front of the car. No. There's a way they are made so that they can be able to cut through the air. So the opposite of this streamlining is this type of shape. So if you look at this, many of the currents will come and push it backwards because there are many. They are not being cut by anything. So I want you to compare this number of air currents and how many will be coming into contact with this type of object. Only one versus this many of them. So that's how we do streamlining. So you streamline to ensure a smooth movement of maybe animals or even vehicles through air or even water. So in movement we don't need friction, especially in air and water. We don't require friction. So that's all about friction, reducing and increasing friction. So our next lesson will be the levers, and we are going to do levers in our next lesson. And maybe to define what a lever is. A lever is a simple machine that is used to do work. A simple machine that is used to make work easier. A simple machine that is used to make work easier. You can imagine of any type of machine that is used to make work easier. Look, for example, the wheelbarrow. A wheelbarrow is a good example of a lever. And a lever, the reason why I call it a lever is because of the parts. So in this case, this chapter, we are going to look at the parts. And then after looking at the parts, the positions, how we position the parts, and then we identify the parts when you are given a question in an exam. So we are going to do three things. We are going to observe what are the parts, how we position them, and identify the parts in a given question. I want just to draw one. I've talked about the wheelbarrow. So allow me to draw a simple wheelbarrow here. A wheelbarrow looks like this. That's a simple type of wheelbarrow. Then just where you can be able to hold. Now, when you talk about parts, there is this rotating part, the wheel. Where the machine makes movement, there is rotation, turning. We call that point fulcrum. It's noted F. Fulcrum. You can write it in full, fulcrum. So that point of rotation, of turning, or support. The point can be point of support, rotation, turning. That is what we call fulcrum. Then we have the part that is carrying the weight, the material. This point here, we call it the load, where the work is being done. Because sometimes you will find that it's not a load, but where the work is being done, that becomes the load. And then where the person applies effort, where are you applying your effort? Where you are applying your effort becomes the effort. Where you are applying your force becomes the effort. And so, in terms of parts, we are going to look at the load, the fulcrum, and the effort. And before we do this, I'm going to give you a formula. Okay, it is going to come on this part here. When given this, how can you be able to know which class it is found? So we are going to do that in our next lesson. So let's meet at that time, be able to discuss this, and you realize many of the machines that you are using at home, they are levers, and maybe you did not know. So from there, you'll be able to identify their positions, the position of the parts, just easily like that, back at home. So until next time, learner, we are through with our today's lesson. May you stay at home, sanitize, and stay safe. May God bless you.